All right, so we go one last one for the first semester. It says find cosine 2x, sine 2x, and tangent 2x. Need your sheet for the whole thing, obviously. So here we go, sine 2x. Sine 2x, you're looking at it as 2 times sine times cosine. Before I even start, I need to know what cosine x is. Remember, this is a 3, 4, 5 triangle because it says sine is 4/5. We're in quadrant 3, so cosine and sine are both negative, so it's negative 3/5. So I'm going to do 2 times sine times cosine. I'm just going to multiply that out. I'm going to get 24 over 25. Cosine 2x, you have 3 options. I'm going to go with the option of cosine squared minus sine squared. If I square cosine, I'm getting 9/25. If I square sine, I'm getting 16/25. Subtract those, get negative 7/25. Tangent 2x, remember tangent is just sine over cosine. If I put the sine over cosine, the 25s on the denominators would cancel. I get negative 24/7. That's all you got to do there. Number 2, the doozy, cosine to the 4th power. Cosine to the 4th is really cosine squared. And if you look up cosine squared on your sheet, it says cosine 2x over 2. Remember, you double the angle. But you have to square that. When you square that, I'm going to square the numerator. I'm going to square, multiply, double, square, all that over 4. If you square 2, you do get 4. Now, because I have that term right there, that cosine squared, and the direction said right in the 1st power cosine, I'm going to square that. I'm going to go 1 plus 2 cosine 2x. Now, if I follow the sheet again, I got 1 plus cosine 4x. You double the angle over 2, all that over 4. You need to make the fraction go away in the numerator, so I'm going to multiply the whole top and the whole bottom by 2. I'm going to go to the left over here. It's going to be 2 plus 4 cosine 2x. And on what happens here is those 2's cancel, so I get 1 plus cosine 4x. It just gets rid of the fraction. On the bottom, 2 times 4 is 8. And I'm pretty much done there, except I can add that 2 and 1. So I'm going to just use my eraser right here and change that 2 and 1 to a 3. And I guess I could change that plus, make that plus a little bigger. And that's your final answer right there. All right, that's a doozy right there. Okay, number 3, half angle. Half angle, sine 15 degrees. 15 is half of 30, which is one that we know. So I'm going to change that 15 to 30 over 2. Follow my identity again. I'm getting 1 minus cosine 30 degrees over 2. Again, just following the sheet there. The plus or minus part, sine 15 is in quadrant 1. Quadrant 1, everything is positive, so I'm going to do plus sign in the front. Cosine 30 is square root of 3 over 2, all over 2. And again, just get rid of the fraction and the fraction. Multiply the top and bottom by 2. My numerator becomes 2 minus the square root of 3. The bottom becomes 4. I do know the square root of 4 on the denominator, so I'm going to leave it like that right there. Take the square root of 4 out. Number 4, cosine 3 pi over 8. 3 pi over 8 is half of 3 pi over 4. So if I were to double 3 pi over 4, I would get, sorry, I said that backwards. If I were to double 3 pi over 8, I would get 3 pi over 4. So 3 pi over 4 divided by 2 is 3 pi over 8. So it's cosine this time. I'm going plus or minus square root 1 plus cosine 3 pi over 4 all over 2. Let's deal with the plus or minus. 3 pi over 8 is less than a half, so it's in quadrant 1 also. Everything in quadrant 1 is positive. Here we go. Everybody knows cosine 3 pi over 4 is negative square root of 2 over 2 because it's in quadrant 2 over 2. Let's multiply by 2 to get rid of the fraction in there. So we're going to get 2 minus the square root of 2 all over 4. And I do know the square root of 4 again, so I'm going to say the square root of 4 is 2. And I'm done with that one. Number 5, simplify by using double angle. Now, if you look at this, it says 2 times sine times cosine. If you look at your double angle, that is basically sine 2x. That is the formula for sine 2x. All right, that's the x. So my answer, I'm just going to double that angle and say cosine 8x. So I don't know why I wrote cosine. Sine 8x. All you got to do. Not much work on that one. Take advantage. Number 6, if cosine is 5/12, well, I don't like 5/12. So let's change that 5/12 to 5/13. Make it a little bit easier. And is in quadrant, well, it doesn't matter. Let's don't change it. Sorry about that. So let's find sine x over 2, cosine x over 2, and tangent x over 2. And then we're in quadrant 1, remember. So quadrant 1 is important because when you do sine x over 2, you do plus or minus 1 minus cosine x, and cosine x is 5/12 all over 2. The plus or minus is going to become plus because we're in quadrant 1. 1 minus 5/12 is 7/12. So I got 7/12 over 2 inside my square root. You can move that 12 to the denominator, so I have square root of 7 over square root of 24. The square root of 24 you can break down 2 on 6. Move the 6 up, make that square root of 42. On the bottom, take the 6 out, you have 12. All right, that's sine 2x. I didn't do a good job. Sorry, sine x over 2. I didn't do a good job labeling that one. Cosine x over 2. It's going to be the same thing, except instead of 1 minus 5/12, it's going to be 1 plus 5/12 over 2. It's going to be positive because we're in quadrant 1 still. 1 plus 5/12 would be 17/12 over 2. Move that 12 to the denominator like we just did a second ago. Get 17 over 24. I don't know the square root of 17. I'm going to leave it alone right now. 24 is really 2 on 6 again. Move that 6 to the numerator. 17 times 6 is 102. Sorry about that. I don't know what just happened. Is 102 over 12. I don't think you can break down 102. That's cosine. These are weird numbers. Tangent x over 2. Tangent x over 2, I'm just going to do the sine over the cosine. Sine was square root of 42 over 12. Cosine is square root of 102 over 12. So you can forget the 12s. Let's reduce that a little bit. Okay, and reduce them. I can reduce them by 2, make that 21, make that 51. This is really an unusual numbers here. So let's move the 51 up. I have to find my calculator real quick. Move that 51 up. 21 times 51. If I could punch it in correctly. Wow. 1,071 over 51. I don't think I'll give you one tomorrow, at least I think I must have made that one up. Those are really weird, very unusual numbers. I'm going to erase that to make some room for number 7. All right, number 7. Number 7 says right there's a sum. It says cosine times cosine. So I'm looking at the sheet where it says product of sum. And if I see cosine times cosine, it says to do 1/2 times, let's see, cosine of u plus v, that's u, that's v, so that's 8x. And then plus cosine u minus v, so it'd be cosine 2x. And all you have to do to finish that, if you need to, is just distribute the 1/2, cosine 8x plus 1/2 cosine 2x. Don't forget, if one of those happens to be negative, a negative angle, you need to deal with that negative angle. And then number 8's going backwards. Number 8 says write that as a product. So I'm looking at sum to product. This one says sine minus sine. So I'm looking down at the very bottom of my sheet for sine minus sine. And I'm seeing this. I'm seeing 2 cosine x plus y over 2. That's x, that's y. So if I do 1x plus 4x, that's 5x over 2. Times sine x minus y, which would be negative, I'm glad this happened, negative 3x over 2. Now, because that sign has a negative, don't forget what the negative sign, the negative goes in the front, so I'm going to finish right here. I'm going to say negative 2 cosine 5x over 2, sine 3x over 2. Now, one mistake people make, that 2 in the front, you cannot cancel that 2 with any of the 2's in those denominators because that's one term, cosine 5x over 2. You're not just saying 2 times 5x over 2. It's 2 times cosine. That's one term. You can't cancel that because that's part of another term. Number 9, find the exact value of cosine minus cosine. So I'm looking at the sheet again. Cosine minus cosine. So I'm looking what I just did. I'm looking for cosine minus cosine. It says to do this. It says to do negative 2 times sine of x plus y over 2. So if you were to add 255 and 195, you would get 450. So I'm going to go 450 over 2. And if you keep looking at it, cosine minus cosine, then you would do sine x minus y. Okay, somebody just walked in my room, had to stop a second. Okay, 255 minus 195 is 60 degrees over 2. Now, let's simplify that a little bit. I got negative 2. 450 divided by 2 is 225. And 60 divided by 2 is 30. And we know those values. That's where we're trying to find the exact value. Sine 225 is negative square root of 2 over 2. Sine 30 is 1/2. I'm just going to multiply those numbers together. This time you can cancel the 2's, those two 2's, which is going to leave me, there's 2 negatives, which is a positive, so I'm going to get square root of 2 over 2. All there is to that one. 1011 says prove the identity, which means we've got to take that left-hand side, make it equal to the right-hand side. So the top of the first one says sine minus sine. So we have one for that, and that's what I'm about to do right here. It says do 2 cosine x plus y over 2, 3x plus 1x is 4x. I'm going to keep this short. Well, I'll write it out. 4x over 2. And then sine x minus y, which is going to be 2x over 2, all over. Then it says cosine 3x plus cosine x. I'm following the same thing. 2 cosine of x plus y over 2, which would be 4x over 2. Look at that. Look at the top and the bottom right now. And then it says cosine of x minus y over 2, which would be 2x over 2. Are you kidding me? So what's going to happen? Those 2's cancel. Those cosine 4x's cancel. That leaves me this. These 2's cancel. It gives me a sine x on the top, a cosine x on the bottom, which just happens to be tangent x. Can't believe it. Okay, number 11. Okay, I'm going to add these fractions together. Let's see the best way to do that. Let's do this. Let's take each one separately. Let's go cosine x over 1 over cosine x. And this one's going to be sine x over 1 over sine x. I'm going to do keep change flip on both of them. If I keep change flip on this one, it's going to give me cosine squared. If I do keep change flip on this one, it's going to give me sine squared. Guess what cosine squared plus sine squared is? It's 1. Number 12, solve these equations. So number 12 is pretty simple. It's just like, where's tangent? Negative square root of 3. 2 places. Remember, it got to give me every place in the first, well, in the 4 quadrants. So it'll be, let's think here. Quadrant 2, 2 pi over 3, and also quadrant 4. Those are the 2 quadrants where tangent's negative. All right, number 13. Got to solve a little bit on 13. Let's move the 1 over first. If I move that 1 over, I'm going to change it to an x. I get 1. Divide by 2. I get 1/2. Take the square root. Take the square root, I get plus or minus square root of 1 over square root of 2. And if I fix that, I'm going to go faster. Just trust me that you get this. You get square root of 2 over 2. Now the plus or minus actually makes this easy. That means you can use any quadrants you want to. You need to use, matter of fact, you need to use all 4 quadrants. So that's all the power 4. So that is like 1 power 4, that's quadrant 1. 3 power 4, that's quadrant 2. 5 power 4, that's quadrant 3. And 7 power 4, that's quadrant 4. And number 14. 14, I'm going to factor. I'm going to show you, so you don't have to do this step. I'm going to let my x, I'm going to put an x in for sine. If ever I see a sine, I'm going to put an x just to make it a little bit easier to factor. I don't have to write sine so much. Let's slide, divide, slide. I'm going to slide the 3. 3 times 2 is 6. I'm going to factor x minus 6, x minus 1, which gives me these 2 answers. Gives me x is 6 and x is 1, which really means sine is 6 and sine x is 1. Now sine x, remember, can't be bigger than 1. It can't be less than negative 1. That's out. And where's sine 1? At the very top of your unit circle at power 2. That's it. All right, 15. Use addition or subtraction formula to find the exact value of sine 15. You can choose any 2 numbers you want on your unit circle that will give you 15. I'm going to go with 45 minus 30. I'm going to follow that addition and subtraction or sum and difference, which would look like sine 45 cosine 30 minus cosine 45 sine 30. Let's just plug in the values. That's square root of 2 over 2. That's square root of 3 over 2. That's square root of 2 over 2. That's 1/2. So I get this is my final answer. If I multiply the first 2, I get square root of 6. The second 2, I get square root of 2. Both denominators are 4, so I'm just going to make it one fraction and put 4. Got it. 16. Got 2 more. Use addition and subtraction to write this one. Okay, that says cosine, cosine, minus sine, sine. That's what I'm looking for. Cosine, cosine, minus sine, sine. When I look for it, it says this. It says cosine x plus y. So I'm going to do 13 power 5 plus negative 1 power 5, which gives me cosine 12 pi over 5. And that's all you do. And the last one, prove the identity. Secant minus cosine over secant. Okay, lots of ways you can go here. But I'm seeing secant over secant. So what I'm going to do is I'm going to break that fraction up into 2 pieces. You can do that if you have more than one thing in your numerator and only one thing in your denominator. But your denominator must stay. The reason I like that is because secant over secant is 1, which I love. And think about this. I'm trying to get sine squared. One thing I know about sine squared is it is the same thing as 1 minus cosine squared. So cosine over secant. Secant is 1 over cosine. So again, I'm going to do keep change flip right here. And if I do keep change flip, that gives me cosine squared. And 1 minus cosine squared is sine squared. Remember, on all those prove the identities, your answer is actually your work. Make sure you show every step on those. All right. Hope this helps. Last test of the semester, well, except for our semester exam. But, last real test. And hope you do great. See you tomorrow.